Reactivity. Redox reactions of metals and nonmetals. We can predict the reactivity of a metal and a nonmetal from their positions in the periodic table. Here's my abridged version of the periodic table. I see the group number at the top in blue and the period 2, 3, and 4 elements shown. Some in red. They are the metals we most commonly consider. Metals lose electrons and become oxidized when they react. More reactive metals oxidize more readily. Group 1 metals are the most reactive as they only lose one electron. Group 2 metals come next. As a group is descended, metals get more reactive. The electrons they will lose are further from the nucleus and so are more easily lost. Potassium, K, is more reactive than sodium, Na, in group 1. It's lower down the group and so has larger atoms, with the outer electron further from the nucleus and more easily removed. Both of these are more reactive than calcium in group 2. Calcium is in period 4 and so is more reactive than magnesium, which is the other metal we commonly think of in group 2. Moving on. After calcium comes aluminium, as it's in group 13. Zinc is next. Zinc atoms have electronic configuration 3d10 4s2. Zinc atoms will never lose more than 2 electrons, as a full 3d shell is particularly stable. That makes zinc more reactive than iron, the atoms of which, with electronic configuration 3d6 4s2, has Fe plus 3 as its more stable ion. Fe plus 3 is stable as it has electronic configuration 3d5. If I look at Fe in my D block, electronic configuration counting across 4s2, 3d6. The 4s electrons and one of the 3d electrons will be lost to make Fe plus 3. Copper is the least reactive metal of the ones we normally consider. Hydrogen is more reactive than copper, but less reactive than iron, and that brings me here. We can start to build up a reactivity series from considering the positions of metals in the periodic table. As I go up from Cu, copper at the bottom, to K, potassium at the top, the metal is more reactive. The metal loses electrons more readily. It's a stronger reducing agent. The metal itself is more readily oxidized. Reactions between metals and aqueous metal ions of other metals show the relative ease of oxidation of metals. It establishes which metals are more reactive. Zinc atoms are more readily oxidized than copper atoms. Zinc will displace copper ions from solution. The zinc atoms become oxidized and the copper ions are reduced. In the ionic equation below I see it. Zinc becoming oxidized to Zn plus 2. Copper ions becoming reduced to the metal copper. The most reactive metals are those which give up their electrons most easily, and so become positive ions. These are the strongest reducing agents. A more reactive metal will displace a less reactive metal from a compound. In this process, the more reactive metal loses electrons and is oxidized. The less reactive metal ion gains these electrons and is reduced. I see it again. Zinc plus iron sulfate gives zinc sulfate plus iron. iron being reduced from Fe plus 2 to Fe, zinc being oxidized from Zn to Zn plus 2. If I tried copper with zinc sulfate, there would be no reaction. Copper, less reactive than zinc. Now moving on to nonmetals. Group 17 elements have atoms that gain an electron when they react. The halogens, as they are known, are reduced to halide ions. And if I look at my 4 halogens, period 2 fluorine F, period 3 chlorine Cl, period 4 bromine, period 5 iodine. As I go up the group, the reactivity increases. The halogen is a stronger oxidizing agent. Why is it an oxidizing agent? It's taking electrons away from an oxidized species. And as I go up the group again, the non-metal is more readily reduced, accepts electrons more readily. Halogens are more reactive. They are more readily reduced as the group is ascended. Atoms are smaller with one less occupied energy level and more attraction for an incoming electron. A more reactive halogen will displace a less reactive halogen from a solution of its salt. The more reactive halogen gains electrons and becomes reduced. The ions of the less reactive halogen lose electrons and become oxidized. For example, looking at chlorine, period 3. Chlorine more reactive than bromine, period 4. Cl2 will displace the bromide ion, forming sodium chloride in this case and bromine. I can look at this with an ionic equation. Elemental chlorine will oxidize Br- to Br2. If I tried chlorine plus sodium fluoride, no reaction. Fluorine is more reactive than chlorine. Halogens get darker as the group is descended. As the halogen gets produced by its ion becoming oxidized, the color of the solution always darkens. That's when I have a more reactive halogen displacing a less reactive halogen from a compound. So, metal reactivity increases and non-metal reactivity decreases on descending a group. Metals lose their outer electrons, they are oxidized and become positive ions. Non-metals gain outer electrons. They are reduced and become negative ions. As we descend the groups, the atomic radius increases as there are more occupied shells of electrons. Metallic elements become more reactive. The outer electrons are easier to remove. Atoms of non-metals also become larger as a group is descended. This means that any incoming electrons are not as strongly attracted to the central nucleus. Non-metals become less reactive as a group is descended and their atoms become larger. Essentially, metal atoms lose electrons when they react. Non-metal atoms gain them, and we're seeing an opposite trend in moving down a group with the metals and non-metals. Quick question to finish. 3 metals were placed in solutions containing metal ions. Tables show where reactions were taking place. So for 2 marks, state equations for the 3 reactions that were taking place. Another 2 marks. Place the three metals in order with the strongest reducing agent first. And identify the strongest oxidizing agent. Bit of a challenge. There's my table showing the reactions of the three metals, copper, nickel, zinc, with solutions. And for my equations, I can see there are three areas where there was a reaction. Looking at zinc with copper ions, zinc, more reactive, reduces copper ions to copper, becoming Zn+2 in the process. For copper, nickel also shows a reaction with a solution containing copper ions. Copper ions being reduced to copper, nickel atoms being oxidized to nickel ions. And my other area where there is a reaction involves zinc and nickel ions. Zinc reducing nickel ions to nickel, and zinc becoming oxidized to Zn+2 at the same time. For my second part, three metals in order, with the strongest reducing agent first. Well, zinc displaces the other two metals, so zinc is the strongest reducing agent. Nickel displaces only the copper, so nickel is the second strongest reducing agent, and copper doesn't displace zinc or nickel, and so is the weakest reducing agent. Now for oxidizing agent. The oxidizing agent must be reduced itself. Cu2 plus or Cu plus 2 is reduced by the other two metals. The ion that accepts electrons most easily is the best oxidizing agent. That's the copper ion. That's it. If you found that useful, please like and subscribe to be informed of more content.